All right, guys, good morning. This is day 2 of geometry, and we went over a lot of basics on Tuesday in terms of definitions and that sort of thing. A lot of those will come in handy as we get more into this even today, start looking at angles. The first thing that we're going to be looking at, though, is this distance formula. I think it's page 6 of your handout. Riri, is that you, Marcia? Help me out there. So, first thing that you see on this page with the distance formula is a graph. I think I mentioned on Tuesday that the distance formula is really a variation of the Pythagorean theory. Somebody, I think, reminded me that that was a squared plus b squared equals c squared. And I'm going to show you in a minute how this specific problem can be solved either of those two ways and why we have to use the distance formula to calculate the distance of this angle on the graph. I mentioned Tuesday that if it was a flat line, a horizontal line, or a vertical line, like if it was across here at -3, it'd be easy just to count the squares and we would know how long that line is. But because it's the diagonal, what we're going to end up doing is creating triangles, right triangles, in fact, and you can use either the distance formula or the Pythagorean theory. So if you look at this first problem, and you want to turn the light off? Go, yeah. Feel free to do that, Audrey. That distance formula, I don't expect you to memorize that. Yeah, that's better. Yeah, but it is something that you need to have as a reference. So keep it handy. And so for this first problem, we got this graph with a couple of points on it. And it just says, find the distance between the 2 points on the graph, okay? We got this point here, okay, which one is that? So if I go left, 1, 2, 3, 4, 5, and up 3, that's this first point. This part of it is just finding the ordered pair numbers, like you would have done in algebra when we were doing these graphs. But we've got to be able to use these in our calculations. So the second point down here goes left 2, so that's -2, down 3, -2, -3 is the second point. So the distance formula involves comparing the x values and comparing the y values. So that's, and whichever one you decide is the first one and the second one, it doesn't really matter. You're gonna label these. If it helps to label them, I would encourage you to do that. So this one here would be x1, y1. The second one would be x2, y2. That way you can just pick the numbers up and plug them right into that equation. So my first point is this one. Second point's here. So what is the x value from the second point?
-5.
Yeah, and somebody's got this backwards. They put the y values here in this first parentheses instead of the x values. I didn't do this. This is something that another teacher prepared that all of us are supposed to use. But I just now realized that because that -5 and that -2, those are the x values. It won't matter whether you put the x values in the second parentheses or the first. Just be consistent. And what you're going to see here is you've got sound is up. You've got to keep change situation in the second parentheses because the equation involves subtraction. In the first one, it's just plugging in two positive, or actually the first one is negative and then the second one becomes negative after you plug it in. Right away, you're going to see that you've got what's not a perfect square. In other words, it does not come out even. We talked on Tuesday about using the calculator. And it's going to look different. If I can get mine to rotate. There we go. If I'm using my calculator, I'm going to plug in tap on the square root symbol, hit 45, hit the equal sign. I get 6.708203932, blah, 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 blah. Never ending string of numbers. If I did that on here, let's see if I can show the calculator. Everybody see my calculator? Where is the square root symbol? Here's the square symbol, so this must be the square root symbol. 45 square root. There it is. And if you notice, I had to hit the square root symbol after I plugged in the number. You might have to do that on your calculator. You get this never-ending string of numbers, and we're always going to round these. They're going to go to the nearest tenth or the nearest hundredth or whatever is being recommended. A minute ago, I said this could also be solved by using the Pythagorean theory. So let me pause this for a second and I'll come back and show you that. So if I take that same problem and I put a point over here, for instance, and another point down here. Once I connect those, that's more or less the line that was on the graph in the handout. -5, comma. It should be down lower. Well, this isn't working at all like I was hoping. So hold on just 1 second. All right, got my little workaround here. So I was trying to say over to the left here, we have this first point, -5, 3. And the second point is -2, And really to do the distance formula, all we need are the 2 points. But if I wanted to do this as the Pythagorean theory, if I created points, not points, but if I took this angled line here and went straight down from the top point and over to the left one, to the right one, I mean, I would have a distance of 1, 2, 3, 4, 5, 6 on this vertical side. So that's my change in y, right? That's 6. Remember, Pythagorean theory is a squared plus b squared equals c squared. Typically, the short side of the triangle is going to be the a value. So that's 1, 2, 3 over. So 3 to the second power. 3 to the second power plus what I just counted here from 1, 2, 3, 4, 5, 6. 6 to the second power is going to equal c to the second power. And what you'll discover later as we get into right triangles is the c side is always the hypotenuse. That's always the angled side that's opposite the right angle. So once I do the calculations, I get 9 plus 36 equals c squared. Same thing, 45 equals c squared. So you're still going to have to hit both sides of this equation with the square root symbol in order to figure out what the root of c squared is. You know, remembering that square root is the opposite of a square, so you're undoing that square. And that can work with almost every graph when you're doing these kind of problems with either the distance formula or the Pythagorean theory.
Hey, Jay.
Yeah.
Can you go back to that screen really quick, please?
This, yeah. Did you have a question?
I'm looking at it really quick. Okay. No, I don't have a question.
Okay. Do you understand where I got these numbers?
Yes.
The 3 and the 6?
Yes.
Okay. Well, holler if you do come up with a question.
Will do. Thank you.
All right. So let's go back to the handout. What you see on these next two problems, they don't even give you a graph. You don't really need it to be able to use the Pythagorean theory, or excuse me, the distance formula. You could do the Pythagorean theory also. The problem, though, when you don't have a graph, is you're not really sure which side is which. Is it the short side? Are they all on an angle? What does this thing look like? So counting squares doesn't necessarily work unless you can use the horizontal, perfectly horizontal and perfectly vertical sides of a right triangle. Otherwise, you can just do the distance formula on every single one of these problems. And it's just a matter of plugging them in. You're going to see the same sort of answers on all of these. If I do the square root of 53, it's another one of these crazy long numbers. And that one you can see has been rounded to 7.3. one of the nice things about the distance formula, and the reason that we have to do these squares in here, because that goes back to the Pythagorean theory, it's going to eliminate any negative numbers that you have. Because like in this problem number 2, -1 and -1 is actually -2. Okay, well, -2 times -2 gives you a +4. So the negatives will cancel each other out once you do the squaring of the term. So you don't ever have to worry about negative numbers or square roots of negative numbers. Because if you remember from algebra, probably algebra 2, you start getting into imaginary numbers that I factor. And thankfully in geometry, we don't have to deal with that because we're dealing with actual shapes, not imaginary shapes or imaginary numbers. Anybody have questions about any of those so far?
No.
No.
The next section on midpoint formula. Anybody know what the midpoint would be? It's a spot somewhere, like if we took this first graph here, somewhere on this line, exactly in the middle, is the midpoint. And because it's on a diagonal, you can't just count it. You have to do more than that. You have to calculate it. And that's what the midpoint formula allows you to do. It's basically, the midpoint formula is averaging. This is another one of these formulas that you need to keep handy so you can work with it. Don't worry about memorizing it, but work with it. Okay? It's the first and the second x values added together, then divided by 2. Well, that's just the definition of finding an average. If your score on 2 tests were, if you had an 80 and a 90, you want to know the average, you're going to add those together and divide by 2. Your answer is going to be 85. The midpoint formula works the same way. So what this really is 2 separate calculations averaging the x values. That's going to give you the x coordinate for the first point, for the midpoint, and then the second calculation where you're averaging the y values is going to give you the midpoint for the ordered pair, the y value of the ordered pair that's right smack in the middle. So again, this is just plugging the numbers in. If you look at this problem number 4 example, find the midpoint of GH, given that G is 7, -5, and H is 9, -1. Then we find the midpoint by doing those calculations. And you notice the formula even has a comma in between the x values, in between the calculations. So that's going to tell you what that point is. So here's my x values, 7 and 9. Add those together, divide by 2. My y values are -5 and -1. Add those together, you get -6. Then you come up with your average, and you've got this value for the point that's right in the middle, 8, -3. Now, one of the things I want to show you is a technique that hopefully will help with some of these problems. The first thing I would suggest is draw yourself a line, because at one end you're going to have 7, -5. That's one end point, right? Because this line's going between these 2 points. 9, -1. And so what you're looking for is this point right here in the middle, which a lot of times you might refer to it as the X midpoint and the Y midpoint. So when you did the calculations, we got 8, -3. So the answer that we got by calculating is 8, -3. Part of the reason to draw these out like this is because there's another variation of using this midpoint formula that involves finding a missing endpoint, where they're going to give you the midpoint and you have to find the missing endpoint. Finding the midpoint itself is pretty easy. You just use the formula. The other thing that drawing this out will help you with is, because we're talking about midpoint here, these distances here that I'm talking about between these points are going to be consistent. So how far is it from 7 to 9? Well, that's only 2. That's 2 positive. So this point here in the middle has to be an 8, because here's +1 and here's +1 for the X values. So if this is just a number line, oops, I didn't want that there. If this is just a number line, these are going to be easy to start to line up. So how far are we going between -5 and -1? That's a distance of 4. We're all in the negative. So if you cut that in half, we added 2 here. We added 2 here to get from the middle to the end point. So either way you go, actually that from here we're going to subtract, you still end up at 8, -3. So if you can visualize that with a little graph like that, that might help you with some of these problems. And I'm going to go to one of these other kind of midpoint problems and show you why you have to do things like that. These first couple examples, just finding a midpoint is not that big of a deal. But now we're given a midpoint here, problem number 1. -1, 2 is M. Our segment is AB. B is 3, -5. I'm going to do this both ways. I'm going to use the midpoint formula, but I want to start off with the drawing to help you visualize this, because maybe that will make this a little bit more concrete. Our midpoint is M. I'll just use M. We have A on one side, B on the other. That's our line AB. The value for the midpoint -1, 2. We know what B is. It's 3, 5. We don't know what A is. So let's call this X1, Y1. Because ordinarily in the midpoint formula, this would be the first point, this would be the second point, A would be the first point, B would be the second point, and M would be the middle point that we're trying to find. So if I do the same kind of comparison visually as I did with that first problem, how far am I going on my x value to get from how far am I going to get from 3 to -1? That's going left 4 on the number line because that gets me into negative numbers. So if I go -4 more, keep going this way, I'm gonna speculate that my x value should be -5. So if I do the same thing with the y value, so the y value is 5, from 5 to 2 is down 3, I go down 3 more. Looks like my y value should be -1. So how do you do that in the midpoint using the midpoint formula? If you don't like doing it that way, that's perfectly fine. What you end up having to do to find the endpoint, though, is do this calculation twice. Because we're trying to find the x of the midpoint. And we've got, I'm going to break this formula out. Normally, we're going to add the endpoints together and that'll give us the midpoint, but here we're given the midpoint. So my midpoint value I plug in out here, -1, 2. And I have one of the endpoints. I'm just going to erase the second one. It doesn't matter which one you decide it is. So my x value, wait a minute, I got too much in there. It should be just -1. There we go. So my x value for my endpoint over here is 5. Now it's just equation solving, find x. So what's the first thing you're going to do with this equation? It's got a fraction in it where x is. So how do we get rid of fractions? Multiply by the reciprocal or multiply by the denominator? Yes, absolutely. Get rid of this fraction over here. We're going to multiply both sides by 2. Right? Because then these will cancel. We'll end up with -2 equals x plus 5. Do I have my x values right? No, I don't. I just realized I grabbed the wrong number here. Look, I was going to get the wrong answer. That's not 5, that's 3. I didn't do that on purpose either. See my, what happened to it? No, it was 3, -5. I grabbed the wrong number. My x value is 3, not -5. Okay. Now it makes sense. Because for a second there, I couldn't figure out why I was getting a different answer than I had when I did the visual. And that just shouldn't be. So there's my endpoint value for x. It should match if I do it correctly. Now, do we do the same thing for the y value? Midpoint y value is 2. Y plus -5 over 2. Multiply both sides by 2. That's just your basic algebra equation solving. Y minus 5 And I did this wrong visually, so now I am gonna get a different answer here. Anybody want to tell me what I did wrong before? Well, when I went from -5, I forgot about my minus sign apparently, because I saw that as only a distance of 3. That's actually 7. It's a distance of 7 to go from -5 to +2. That's a distance of 7, not 3. So I should have gotten 9. I hate trying to write with this pencil thing on this whiteboard, but it's because my writing is bad enough as it is without getting on here and being extra sloppy. So I didn't do that on purpose, but when you try it maybe both of these ways, you can also perhaps catch a mistake. It's a way to sort of check your work. So if I go from 2 + 7, that should give me 9. Questions, anybody? All right, now what I'd like to do is to take problem number 3 and pause the recording so you guys have a chance to work problem number 3. Finding the midpoint's easy. These are a little bit more difficult. So I'm going to give you a couple minutes. Take some scratch paper, see if you can use that midpoint formula. Let me go back to the midpoint formula so you can see what that is. And I'll even show you that first problem that I just did. Yeah, it confirms I did my visual part of it wrong. So now you can see both of these original calculations. Here's the calculation for X involving the midpoint that you already know. Here's the calculation for the Y value for the other endpoint, because you already know the midpoint and one endpoint. So see what you can come up with for number 3. So here's my visualization set up for that problem number 3, where I'm trying to find the missing endpoint. I'm taking everything that I can use and plugging them into the equations from the midpoint formula where I can. Here's my midpoint. Okay, normally that's my outcome. I have a midpoint for X of -1. I have a midpoint for Y of +3. I have one of the X values on one endpoint, so I can put that in here on 1/2 of the formula. And then I have the X value the Y value that I plug in for the other half. But before I do the calculation, you should be able to do the calculations just from this, but I want to do my visualization again to see if I have this correct. How far is it on these X values from 5 to -1? That -6. So because it's a midpoint, I got to move the same distance to get to the other endpoint. It has to be the same or it's not in the middle. So if I go from -1, -6 more, should be -7. So that looks like my X value for the other endpoint. Do the same thing from the Y values. From 6 to 3 is down 3 more. Should be 0. So that's my prediction for what my calculation should give me if I've done this correct. So let's go back to these. Times 2 times 2. I got -2 equals 5 plus X. Take away 5. because now I'm solving for X. Does that match my predicted X value? Yep, sure does. So all I'm really doing is I'm taking this midpoint formula and I'm splitting it into a calculation for the X value and a calculation for the missing Y values. I haven't changed the formula. I'm just using it a little bit differently than if we were just finding the midpoint. It's still the same formula, and there I got 0 for Y. And that is the point that I predicted, -7, 0. So what I would encourage you to do is take some more of those problems that are in that handout and practice with them. You know, this video will get posted tomorrow. You can always come back and look at this again. The other thing that I would encourage everyone to do is to go to, I'm going to pull this up here in just a second. If you're not familiar with this website, Khan Academy, I would encourage you to go in and create an account. You can use your Excel Center email address. It will, you can see right here, this is my account. This is all the stuff that I've worked on over time. It keeps track of everything. And if I need to help with something, if only I could type today, midpoint formula. Look, I didn't even finish it, and it comes up midpoint formula, distance and midpoint. And right there, I'm going to have, there's some practice. Here's a video, how to find the midpoint. Distance formula, midpoint formula, distance and midpoint, midpoint formula itself. A bunch of different calculations are possible here, a bunch of different videos that are available to you. And if you have an account, it will keep track of the, it will keep track of this, it will keep track of this stuff, and you can go back to it and use it again and again. You don't have to just rely on the stuff that we do in here. I don't want you just to rely on that. Khan Academy is one of the best resources that are out there, and it's free. So make sure you get in there and get an account set up. So it's going to go back to the handout. Because now what they're going to do is try to make this midpoint stuff more complex. Like if you look at problem number 6, it says use the diagram to the left if line N bisects the segment QR. Find QP. Okay. It doesn't tell you that that point P is the midpoint, but you should know that. And why do I say that? Because it's using the bisection. Go back to your definitions. What does it mean when we have a line bisect another line? It cuts it in half. That gives you the midpoint. So find X. What does X equal? You got to find X to be able to find how long the measurement of QP is. So how would you set that up? Does QP equal PR? Everybody should be hopping up and down saying, yes, Mr. Alley, that's the midpoint. They have to be equal to each other. They are equal to each other. So 3x plus 5 equals 5x minus 19. Now find x, then you can find how long QP is. I've already said a couple times, remember the definitions will come back to you again and again, and that's a perfect example. So the rest of this handout packet is involving angles. Finding angle measurements, describing them, categorizing them. And again, more definitions, more stuff to remember. But some of it goes back to the original definition sheet also. Like if you look in the middle of this page here, the types of angles, acute, obtuse, right angle, straight angle, those are all in the definitions. It's just giving you a graphic representation. Here though, now I think is maybe even an additional description of what an angle is. Formed by two rays with a common endpoint. Well, if you don't know what a ray is, that might not make sense. So you might have to go back and look at those definitions from the first day. Nothing new here in the rest of that, except for this piece right here. Naming an angle. You have to use 3 letters. I mentioned this on Tuesday. The middle letter must always represent the vertex. So I could describe this angle to the left here as angle ABC or angle CBA. No other way, because B is the vertex. And the reason that this is required is because you're not always going to have a drawing, but you can rely on the ordering of the letters to know where the vertex of a given angle is. So that middle letter always has to be the vertex. Right below that, where we're talking about the measure of an angle. Angles are measured for us in degrees. They're also measured in radians, but we don't have to worry about that. It's not part of what this course involves. You might learn that later if you keep going in your math. But that lowercase m means the measure of this angle is 60 degrees. So that would be an acute angle. It's less than 90. So you start looking at these examples here. Some of these are going to be pretty obvious. Name the vertex of the angle. Well, it's K. Name the sides of the angle, KL, KJ. You have 3 ways to name the angle. JKL, LKJ, or just angle K. Now, why can't I just call it angle K? Not the midpoint.
Oh, shoot, you're right.
K is the vertex.
Yeah.
And there's only one angle that's shown in that example. So there's no possibility of confusing this angle K with some other angle. So if you have that situation, then you can just call it by the vertex. When you get a multiple angle situation like this next example, now you have to use 3 letters. So what's the vertex of angle 2? Anybody at home? The vertex of all of these angles is at T, right? Point T. Where are the sides of angle 4? Well, here's angle 4, WTZ. So WT and TZ would be the sides. Another name for angle 3, okay? ZTU, UTZ. Cannot say angle T though, even though T is the vertex. It's the vertex of all those angles, so that would really be confusing. Now these last 4 things on here where it says classify, when we're classifying angles,
is that like a right triangle or a right angle, obtuse angle, acute angle?
that's exactly what it is, Audrey. When we say classify, this is what we're doing. We're trying to figure out which one of these categories a given angle fits in. A lot of times you can do that just visually. You know, acute angles, they're more closed. Obtuse angles are big open angles. Hopefully a right angle will either have the box in the corner or it will say it's 90 degrees. So if we're going to classify some of these angles in this example 2, where's YTW? YTW, okay, that's a right angle because the box is right there. That tells me it's a right angle. YTU is the next one. That looks like it's obtuse because it's bigger than 90. Hopefully, by looking at this drawing, and here's something that you're going to have to get used to in geometry also. Sometimes you're going to have to ignore parts of the drawing for the rest of it to make more sense. And what I mean by that is if you ignore this ray here from T through U, what you have in this intersection here is 4 right angles. And 2 and 3 are splitting this right angle into something less than a right angle. But you put them back together, it's still a right angle, because if 5 is a right angle, 1 has to be a right angle. Remember, once you determine that, then you can go back to your definition of vertical angles, where the opposite angles at an intersection are going to be congruent. So that means 1 and 4 are also 90-degree angles. And again, if you combine 2 and 3, they would also be equal to 5. And you can see that they're all right angles around that intersection. Has to be, or something's wrong. The next page is formatted awkwardly, so I need to rotate it.
Oh, is it the one with the bubble thing?
Yeah, it's just a graphic. Yeah, here we go.
Oh,
This next page is another way to put all these relationships in one place together. I just mentioned vertical angles, linear pair. Here's a really good drawing of a linear pair. You ought to try to get these visuals into your mind. And it's not just the definitions anymore. These are actual situations where you're going to need to know what these mean, because now you're going to have to start figuring out angle measurements. Like look at supplementary, look at the drawing for supplementary and linear pair. The drawings are basically the same. So if you understand the definition of linear pair, that they equal 180 together, if you know what one of the angles is, then you can calculate the other one. Vertical angles, they give you the congruencies here. 1 and 2 are congruent, 3 and 4 are congruent. They don't have any measurements on there, but because they're vertical angles, we know that that's true. So this would be, if you like these kind of graphic organizers, this would be a good one to get filled out. Next page is just more of the same. And then you go to the page, what page is this? Page 11. Now we got to start finding these missing angle measurements. So if you look at the first drawing there, that first example, how much is angle X going to be equal to? The first thing you need to ask yourself is, what's the relationship between those two angles? Are they linear pair? Are they supplementary? Are they complementary? Are they vertical angles? They're vertical angles, so X is also 112. How much is X in problem number 2?
68.
Nope. X is not 68. Can't be. The other part of the angle is 68.
22.
22, yes, because the box in the corner here tells you that this is a 90-degree angle. You can't forget that. So together, these can only total 90. So 90 minus 68 is going to give you X. Angle X in problem number 3. Not X.
No, the other one.
Yeah, it says 124. The obtuse part of that pair of angles is 124. So is this a linear pair? You should be thinking, yes, this is a linear pair. So these have to equal 180. So X has got to be what's remaining after you subtract 124. It's more than that.
36. 46? Dang it, I can't do that.
56. 180 minus 124. I don't care if you use a calculator on this stuff. You might need to. I mess up all the time when I try to do these in my head. I can't hardly do any easy calculations anymore just by thinking about it. So that's number 3 is an example of a linear pair. There's the definition again. Number 4 is another vertical angle. So now I can find all of these angle measures just by knowing that one of them is 43 degrees. Because that means angle Y is also going to be 43. It's opposite. X and Z are going to be equal. Z and 43 together make up a linear pair. So 180 minus 43 is 137, I think. So Z and X are both going to be 137. So all these problems where you're finding angle measurements are going to be like that. You get down here into 6 through 9, make yourself a drawing. Angle 1 and angle 2 are vertical angles. If the measure of 2 is 105, find the measure of angle 1. If you don't know what a vertical angle is, go back to your definitions. Create the drawing. Vertical angles are created when any two lines cross. So if this angle is 105, what is that one? Vertical angles.
Oh, wait.
Anybody at home? You still awake out there? Put it in the chat if you don't want to say it out loud. I need somebody to give me an answer before we move on. Well, this is going to be hard for you guys if you don't recognize what this one is. This is the easiest one in the whole page.
Is it also 105?
It is also 105. Yeah, it has to be. It's by the definition of vertical angle. Angles that are opposite each other are congruent. So what did I say before? Keep the definitions close by so you can refer to them. You have to be able to do that in order to solve these problems. So if we go back to this handout, now you got to apply some algebra. PQT is 3x plus 47. PQT is 3x plus 47. SQR is 6x minus 25. Well, that's another vertical angle situation. So those two angles are going to be equal to each other. So all I have to do to solve this is set up the equation so that those expressions are equal to each other. 3x plus 47 equals 6x minus 25. Because this angle up here equals this angle down here. They're vertical angles. And you will see problems like this on this first unit test. So what I would encourage you to do before you take the test is to use this study guide that is at the end of the handout. You don't have to do every problem. Do some of these problems. Find the ones that you don't understand. Take a photo of them. Take a photo of your work. Send it to me. Let me give you feedback on it before you take the test. I mean, if you're feeling comfortable with it, great, go for it. Again, don't forget, everybody, you can always take tests twice. I have an alternate version. I'm sure you don't want to do that, though, if you can avoid it. So we're out of time today, guys. Go back through those definitions again. Anybody have any questions? All right. I will see everybody on Tuesday, hopefully. You know, don't have class tomorrow. I've got some things to do. So if you text me, I might not be able to get back right away, but don't hesitate to text me anyhow, even this weekend. See y'all. Thanks for coming this morning.